Hey guys, this is Sinchana graduating in Sri Venkateshwara College of Engineering. Today the topic is test of signification of means of two sample spaces which we study in data structure and its application. We'll see. We'll see the test of significance of means of two small samples. Introduction of significance testing. Significance testing is a statistical method to determine if there is enough evidence to reject a null hypothesis. It's a crucial in research for making inference about the population parameters based on a sample data. This presentation focuses on the testing the means of two small samples. Importance of a sample size. We'll start with the basic for the importance for the sample size. The sample size can greatly influence the reliability of the results. Small samples may not fully represent the population, leading to potential biases. Understanding how to test the small samples is essential for accurate statistical analysis. The null and alternative hypothesis. The null hypothesis typically states that there is no difference between the means of the two groups. Alternative hypothesis suggests that a significant difference exists between the two group means. Clearly defining this hypothesis is critical for the conducting the significant test. Types of test of means. The t-test. The t-test is commonly used when comparing the means of two small samples. Different versions of t-test exist depending on whether samples are independent or paired. The choice for the test affects how we interpret the results of an analysis. Independent sample t-test. The independent sample t-test is used when the two samples are from a different groups. It assumes that the two groups are approximately normally distributed. This test evaluates whether the means of the two groups are statistically different. Paired sample t-test. The paired sample t-test is applied when the samples are related or matched. This could occur in before and after studies or when subjects are matched with certain characteristics. The focus is on the difference between the paired observation. Assumption of t-test. Both type of t-test has assumptions that must be met for a valid result. Key assumptions include normality, independence and homogeneity for the variances. Violation of these assumptions can lead to inaccurate conclusions. Normality assumptions. Normality means that the distribution of the sample means should be approximately normally distributed. This can be checked using graphical methods like QQ plots or statistical tests like the Shapiro-Wilk test. If the sample size is small, normality is particularly important or validate. Homogeneity of variances. Homogeneity of variances means that the variance in the two groups should be approximately equal. This can be assessed using Levin's test or F-test for the equality of variances. If this assumption is violated, adjustments may be necessary. Conducting a t-test. For conduction of a t-test, first calculate the sample means of the standard deviation of both the groups. Next, determine the t-statistical using the appropriate formula for the type of t-test. Finally, compare the t-statistic to the critical value from the t-distribution scale or a table. The formula is given by t is equal to x bar is the mean of the sample minus mu is assumed mean divided by sigma of the standard deviation divided by root of n. N is the number of observations. Interrupting the t results. The result of the t test will yield a p value indicating a probability for observing the data. The low p value, typically less than 0.05, suggests that there is no significant evidence against the null hypothesis. Conversely, a high p-value indicates insufficient evidence to reject the null hypothesis. Reporting results. The result should be reported clearly starting to the means of standard deviations, t-statistic and p-values. It's also important to mention the confidence intervals for the more comprehensive understanding. Transparency in reporting enhances the credibility of the research findings. This formula is given by t is equal to x bar minus mu naught whole divided by s by root n, where x bar is a sample mean, mu naught is a hypothesized population mean, S is a sample standard deviation, N is a sample size. Practical application. The t-test is widely used in various fields including psychology, medicine and social science. It helps researchers to make the data-driven decisions based on a statistical evidence. Understanding how to conduct the interrupt t-test is essential for the effective research. Limitations for the t-test. T-test have limitation particularly when sample size is extremely small. They are sensitive to outliers which can skew results significantly. Researchers should consider these limitations when drawing conclusion from a t-test. It may have the population size, confidence level, the margin of the errors and the standard deviations. Alternative test for the sample spaces can be determined when assumptions for the t-tests are not met. Alternative tests may be more appropriate. Non-parametric tests like a Mann-Whitney U test can be used for independent samples. These tests do not assume normality and can be more robotized in current situations. Software for t-test can be statistically software packages like SPSS, R and Python may conducting t-test straightforward. These tools provide built-in functions to streamline calculation and interruptions. Utilizing software can reduce manual errors and enhance efficiency in data analysis. Common mistakes to avoid. The common mistakes is ignoring the assumptions for the t-test leading to invalid results. Another frequent error is misinterpreting p-values leading to incorrect conclusions. Ensuring clarity in hypothesis formulation is also critically to avoid the confusions. For the case study, like example for the case study, if we consider a case study comparing the effectiveness of teaching two methods in a test source courses. Researchers should use an independent samples t-test to analyze score from two separate classes. Results would inform decisions about which teaching method can adopt based on a statistical evidence. Future directions on the research. Ongoing research is needed to improve methods for analyzing small samples. Development for robust statistical techniques can enhance conclusions drawn from the limited data. Collaboration between statisticians and the researchers can lead to a better practices. For the final conclusion, the test of significance for means of two samples is a fundamental statistical tool. Understanding its applications and assumptions is vital to accurate data interruptions. Researchers must remain vigilant about their methodology and ensure valid conclusions. Thank you.